So, super expensive, but not the most sexy of topics is RAM. A board like this actually, funny enough, doesn't take traditional DDR5 RAM. It specifically wants ECC DDR5, which is server-grade error-correcting memory. The difference between this type of RAM and the type that you would slot into a gaming computer is mainly two things. One, every now and then, on these types of systems, a bit could flip the wrong way, inside your RAM. Usually not too critical. In a game, maybe that might cause like a crash or something like that. In AI and inference, the system has no way of telling the difference between essentially corrupted and non-corrupted data. It's this big giant matrix that's making these probabilistic decisions. So if something flips the wrong way and it doesn't get caught or it doesn't get detected, it just gets processed as though it's correct and part of the data set. And then you can get an answer that seems correct or seems plausible, but has slight details in it that are wrong that might be difficult to detect. So error correcting memory, whenever you get these weird bits that flip accidentally inside the hardware, it catches that, corrects it, and then just keeps things moving. So that's something that as an investment doesn't seem very critical when you're using this stuff for gaming or traditional office tasks. Like, what's that one bit going to do to me? But in LLM inference, it becomes a genuine standard that people build around. The other thing is these have registered memory chips on them. So one of the interesting things about registered memory versus traditional DDR5 is essentially traditional DDR5, the CPU has to manage the RAM itself. So if I slot two cards worth 64 gigabytes onto my gaming PC, the CPU is actively watching and managing that RAM. I slot it to 4 cards, it's actively watching, monitoring, and working with it. As cards expand, as the quantity of memory goes up, that can be really strenuous and demanding, not just electronically, but on the CPU itself in terms of a load. So what registered memory has is essentially a chip on each stick that serves as like a coordinator, for the rest of the RAM that sits on that stick. So rather than one CPU trying to keep track of all of these chips individually, the CPU is coordinating with that one chip, and that one chip is coordinating with everything else on the stick. What does this give you? Scalability. So a traditional board might be able to go up to like 128 gigabytes of RAM. This particular board, we're not going to do it. But this particular board could go up to 1 terabyte of DDR5 RAM, which is just absolutely insane. And you can't achieve that scalability without registered and managed memory. It would just be a nightmare for the CPU to stay on top of. So we've got 256 gigabytes of this memory between 8 cards, and that's all going to slot in to our motherboard shortly, and that's our RAM.